Unit 6 begins with a flashback where we think about our old trigonometric functions and how they work. Everything's based off of the right triangle that you see in the top left, where we're going to have an angle theta. We're going to have the side across from it is called the opposite side. The side directly next to it is the adjacent side. And then our longest side, which is counter to our right angle, is going to be the hypotenuse. Well, we know three trigonometric functions that we've defined so far, and we'll use these in this unit a lot. The first one is that if the sine of an angle is the opposite side over the hypotenuse. We know that the cosine of theta is our adjacent side over the hypotenuse. And we know that our tangent of theta is going to be the opposite side over the adjacent side. We'll learn. Think of it this way: if you're looking at a triangle, then you're looking at a ratio of two sides of a triangle. Well, the sine is really going to learn to represent how tall a triangle is. So the bigger the opposite side is, the taller that the triangle is, the larger value of sine you're going to see. When you talk about cosine has to do with this adjacent side. So it's dealing a lot with how wide a triangle is, or kind of like how fat a triangle is. The wider a triangle is, the bigger the value of cosine. And then tangent represents the ratio of the opposite side, and the adjacent side. We call this rise over run. And so it's actually representative of the slope. So if we can kind of think about what a triangle is going to look like, where it is, and we could think about how steep it is, that's what tangent represents. So let's look at a problem. This problem down here is asking us, I know you all don't see the actual question, but it wants us to find this angle A. So how do we go about angle A? So we got to think about, what do we have here? Well, we have its opposite side, but we don't have any other information. So I got to figure out how to find one of those other sides. If I look at my triangle at the bottom, I have an angle, opposite side. Well, since this side here is what's connecting to the other triangle, I'm going to try and use something that involves all three of those. So I know that, let's say, the sine of 28 degrees equals 12 over x, or over that hypotenuse. I can do very quickly find, like, say, hey, x equals 12 divided by the sine of 28. Now, I don't know the sine of 28, but I can use my calculator. So make sure, we want to make sure that we're in degree mode. Whoa, what's going on? So we want to make sure, see, I'm in radian mode, so this would have been bad news. We'll talk about radians in just a second. And so if I do 12 divided by the sine of 28, gives me x, which is 25.5606. Now, what I'm going to do is I don't want to have to type that number in again because I'm lazy. So I'm just going to store this as x, because I hit the store button right above on. I'm just going to store the answer into x, and that way I can use it later. Now, if I look at my new triangle, I now have, let's see, I've got alpha, its opposite side, and now its adjacent side, which is my x. Well, I know that the tangent of alpha is now going to be 20 over x. Well, that means the tangent of alpha is, if I go back to my calculator, so 20 divided by x is 0.78242, blah, 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 blah. So my tangent value is less than 1. Now, how do I find out what angle goes with that? Well, not so hard. These, right here where it says sine, cosine, and tangent, if I use these little -1 buttons, so like second tangent, if I input a value of tangent, it'll tell me where the angle is. So I'm going to input the value of the answer here into my inverse tangent. It tells me it's 38.04 degrees. So we've got alpha is 38.04. So just how we can do different things. Sometimes we can solve for sides, we can solve for angles. Everything can be done on your calculator, which is very nice. Now, they didn't used to have calculators, so instead of having to deal with these wild angles, what they did is they created a new way to talk about angles, and that's where we call it's called radian measure. So their logic here was, okay, well, if I go, every circle has a circumference of 2 pi r. Well, if we think about it, how many radii does it take to go around the circle? Well, if we think about this formula, it takes 2 pi radii to go all the way around. So instead of saying, hey, we've got 360 degrees, now we're saying, oh, well, actually we have 2 pi radians is what we're going to call it instead. So a measure of a radian is the angle created by moving 1 radii around the circle. Okay, so that's what it's called. So we start to see this measurement show up quite a lot, and I'll talk about it extensively. But ultimately, 2 pi is the same thing as 360 degrees. So 1 pi, which we use a lot, is the same as 180 degrees. So you're going to see some weird angles listed, like you may see pi over 3. Oops. Well, pi over 3 is 180 divided by 3, so it's just 60. And you may have pi over 4, which is 180 over 4, which is 45 degrees. So you're going to see this show up quite often, and it's just to make the calculations easier. It's easier to multiply by that than it is to multiply by 45. So just keep that in mind as we move throughout the unit.